Hello developers, let's start developing. My name is Veko and we will be taking on the 18th day of the 2021 Advent of Code. I've looked through the code, through the test, through the puzzle, and to be honest it's a bit confusing. We encounter some snailfish, which are apparently some kind of fish, weird fish. And they need help with the math homework, and they use an extremely convoluted way to do addition. So each snailfish number is basically consists of two parts, and the first part and each part of the numbers can be a snailfish number, which means that all of these are valid snailfish numbers. For example, if we try to analyze this, it will always be a perfectly matched set of two values. So each snailfish number is basically always consists of exactly two values. Let's have it like this. So this one and this one, and this one has this one and this one, and you can see this one is all the way above. So we're furnished with the first part of the original number, and the second part of the original number is this. I guess. So each number has only a single comma inside of it, and that means that this is a one number. So this is a snailfish number, this is a snailfish number, and this is a snailfish number, and all of this is a snailfish number as well. So this is on the 0th level, this is on the first level, second level, third level, fourth level, or according to the task, let's call this the 0th level, then the first level, on the second level, on the third level, and on the fourth level we have the actual values here. So this only goes up to the fourth level. Up to the fourth level, but all of the fourth level values are actual numbers. So I was thinking about making into some sort of a recursive structure that this might be okay to model it. Something like a definition. Let's say we have it has a left part, which is a snailfish number, and the right part, which is a snailfish number, or an actual number, and we can do something with that. But after that I got that we actually need to reduce them. That means we need to know something like we need to know both its level and its actual linear structure, so to say. So we have this. To reduce a snailfish number, you must repeatedly do the first action in this list. So basically we need to do some operations on this structure, let's call it. It's not a number. So if we have a pair that is nested inside four other pairs, which means if on the fourth level, as we're counting it, we had an item. So if this was instead of a regular number, if this was some kind of a snailfish number, this would have been a candidate to explode. Kaboom. And what does explosion means? it means that we need to find the number that's to our left or the number that's to our right and basically distribute the values. So for example, if we have this situation, let's take a look at this. Okay. So we have this situation, and if we take a look at it, now this, and this. So we have the 0th level, the 1st level, the 2nd level, the 3rd level, the 4th level. So on the 4th level, we have this. So in other words, we have a line of 1, 2, 3, 4, 5 brackets. So if we have a line of 5 brackets, that means that we need to explode. And let's see how this thing explodes, where it finds the first regular number to the left of it, or in our case above, and the first regular number below it or to the right of it. So this thing goes here, and we just add it. It becomes a 7. This thing goes here, and it doesn't matter how far away this is in the tree structure. So this becomes 3, and this whole thing becomes 0. So if we had a tree structure, we would need to find sometimes it will be a sibling, sometimes it will be a cousin or a parent or a grandparent or whoever knows what. So that part is not really easy to do. So I'm thinking about managing this somehow linearly, managing this thing somehow linearly. So we're gonna find out, we're gonna count the brackets, 1, 2, 3, 4, oh, we got on the 5th, find the 6th, and we are kinda guaranteed that we will get 5 tops. We will never get 6, because that would be an invalid number or whatever. So if we get 5, we get 5, and then we can just backtrack, find the last number, and this is a 4. So we will need to yank the pair somehow, and from this point go back to find the number and add the first one. From this point go forward to find another number, add this, and put a 0 here, and repeat. That's the first operation, and that's how I feel that I will try to implement it, by searching through the string, so to say. So, and to split a regular, and the splitting is kind of the opposite, because we are exploding will always reduce the level. So we always losing a number, so to say, when we are exploding, and splitting is the other way. Splitting will generate another number. To split a regular number, replace it with a pair. The left element of the pair should be a regular number divided by 2 rounded down, the regular number divided by 2 and rounded up. So 10 becomes 5, 5, 11 becomes 5, 6, and so on. Okay, that's straightforward. So this means that we will never get a number that's bigger than 10 that we will need to explode. The only way to get a number bigger than 10 if its neighbor explodes. Actually, is that true? Is that true? Let's see to find a counter example, so to say. What would happen if instead of 9 we had, so this is a place when we have 1, 2, 3, 4, 3, 2, 3, 4, 5. We're exploding this one. 4 and so on and so forth. But what would happen if we had a situation when this is also a pair? Is that valid? Well, it has to be, since any number can be replaced with a pair. So what happens after we explode this? So that means that this number gets to go away and gets replaced with a 0, and this 7 becomes a 15 and this 9 becomes a 13. So what is the next operation that we want to do? Well, we're gonna need to explode this. Yeah, we will need to explode this because 1, 2, 3, 4, 3, 2, 3, 4, 5. But it will never be a case when we actually need to explode this, so to say. So we will never have the thing inside the explosion might have a value, but the thing outside of the explosion cannot be larger than 15. So there's no way that we might need to add the 13 to the 15. At least I think so. Anyway, let's start. Processing the input will be straightforward, only I have no idea what to process. We have this example, for example. Yeah, this is the trivial value, and this is the not so trivial. The first not really trivial example, when we do have something to do. But we will need to have a method that is called kinda reduce. And I will just use a string. This will, when given a Snellfish number, try to reduce it by exploding it and splitting it and whatnot. And I think this is the most complicated part. And then we will need to do addition, and that will be kind of simpler. First, which is a string, and second, which is a string, and it says that the addition of two numbers form a pair from the left and the right parameter. That's all we need to do. So just to add two numbers as strings, we will just need to do a return, not first plus second, but we're gonna add a bracket, then the first one, then a comma, then the second, then another bracket, and that's all we need to do. with the single thing that we're gonna need to reduce this. So our addition is kind of implemented. So we're adding, reducing, adding, reducing. The simple thing is that we need to do the actual reduction. And the thing says, try to find an explosion. So we're gonna say, well, true, and let's have it like this. Try to find an explosion. If we have an explosion, and continue. Restart the while loop. Split is find split of the input. Yeah, this is basically a pseudocode. If we have a split, we need to process the split and restart the process. Otherwise, this means that we don't have a explosion and we don't have a split, and then it's a reduced value. So we're gonna copy over the input into the result, and we're not gonna be finding inside input, we're gonna be finding inside result. Let's have it like this, a boolean, and just do this. We're gonna do an explode, or we can call this success. So if we successfully exploded it, we just do continue. We can do the same thing, not with the implode, but with the split on the result. And again, if we have success, because detection and processing is basically the same thing. The processing itself is quite simple, the detection process will be problematic. So we just need to explode into a result or split into a result, and each of these will return a tuple of the operation success and the actual result. So let's have explode is a function that takes an input as a string and returns an array of boolean string. Let's just have it so this is happy, return true input, and of course split will be much the same, only I will return this false. I just want to see if this kinda sorta weird way runs. So we're gonna need to test reduce on a this. This is our test case. back, we want to run test. So all of this was basically to try to break down our problem to a bit of a smaller problem. And yeah, this kind of looped, because if we are successful in exploding, we are resetting the loop. Yeah, and if we are not successful in exploding, this will just say split, 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 because explode will always, yep, do that. Okay, so we actually need to find the explode. What do we need to do? We can have a stack and a count of brackets. Actually, do we need a stack? We need an index, and that's a 0. Get the character. If the character is dead, then bracket count is +1, else bracket count is -1, and bracket count need not be a actual value. So I'm gonna keep index out of this definition because I'm gonna want to use it outside the loop. So basically, if our character is open bracket, increase the bracket count. If the character is close bracket, decrease the bracket count. And we're golden. And we need to panic if bracket count is 5. Break. And let's have a boolean, then we're gonna call it found, and that equal to false. Otherwise, we just say we found it. So, if we haven't found it, that means that we didn't anywhere in our string found a 5th bracket, so then we are returning false. And let's just put in one more thing that I think will be interesting. Yeah, the bracket count will obviously be 5, but let's say input or result input dot slice off starting at index. Let's see what we get. We just need to call it once. Yeah, so we're just breaking off the while loop because we want to run it once. Actually explode at index 4, and this is the value that we have, 4, 3, and so on. And that is where we actually want to explode. So if we started with this thing, I think we should want to explode at 8, 4. Yeah, index 16, 8, 4. So explosion detection is kinda complete, so to say. Somewhat. Yeah, so we know the index at which we want to explode. And now we need to find basically the next closing bracket. Let's do that. Let's find the next closing bracket starting at indexed. And we more or less need to slice that off. Start at index and end at this index. Actually, let's write that out to see what we're getting. And let's call this both with this example and the other one. Do we have another explode? Yeah. This will need to explode 6 and 7. Let's see what we're getting. We need a +1. No, we didn't want to add 1 to the slice, we needed to add 1 to the index of that one. So we just went to 4,3 and added the string 1. Yeah, JavaScript is fun that way. So this is the thing that we want to explode. And now I wanted to use regexes a lot more, but for this it will be okay. So this is a string that should be always in this format. We're starting and then there's a literal bracket and then a number which could have multiple digits. I really don't think so, but it's better to be safe than sorry, and then a literal closing bracket and then the string ends, and I actually want to get these two values, 4 and 3. Let's actually and then we have the string 4,3 and we need to match Eric's. We have 3 matches and those are the first one and the second one. We can also use Eric's test 4,3 and we're getting test, or we can use exec and we're getting something like this, which is very similar to what we got before. I like this part, this format best. Yeah, I'm gonna be pasting regexes so we can say, let's call that boom, and that's this thing. That's the thing that we want to explode. We need to do boom match using Eric's If we don't have a match, we didn't get a kaboom. And for this. And note that we do have the index. No kaboom for boom. Okay, but if there is a kaboom for boom, yeah, that would be okay if we wanted strings, but we actually want to have numbers. We want to have numbers. Do we want to have numbers? Yeah, we do. Yep. That's it. So now we have the index. So we know that at this point on we need to do that. And come on. We need now to find the number to the left. We have these three cases, and I think these three cases cover everything. So we're exploding here. The number to the left needs to be found in this string. And for 8-4, the number to the left needs to be found in this string. And for 6 and 7, the number to the left needs to be found in this string. How do we do that? And let's say, for sake of completeness, that we might need to find this string as well. Well, one way to do that was to do a regex, but regex are awful at matching from the wrong side, so to say. We can always flip the string and search from the front, but that would be too bizarre even for me. So, actually, would it? Negative look ahead, and this can actually work. Let's try it. So we need to find at the end of the string, yeah, we found the end of the string, and it can have anything that's not 0 through 9. And then it should have multiple digits. And this should happen any amount of times. Now it should, yeah, basically it's not anything that's not, but it can be literally open or close or comma. Can there be a close? Yeah, why not? Basically, if we are exploding and we're closing, yeah, there could be a close if we are exploding the first part. So if instead of exploding this value here, we exploded this value here, then the first previous number would be a 4. So if we put it like this, yeah, this is what we need. And one more thing, since we're starting with what we want to do, and now will this work? Let's say this dot match on the Rx. So we're getting that the index that we're looking at is 20. So we need this value and we need this value. At index 20, there is a value that we need to change. Of course, it didn't guess the correct regex, but we will have this. So we just need to say input dot slice from 0 up to index match on the left regex. And that's the left match. If we don't have a match, actually if we do have a match, then it's okay. Else do nothing, because in this case we don't have a match and we're just not doing that. Otherwise, what we will need to do. We don't have a result here. So the result will be we will need to do is the input, and we will need to mangle the result in order to get it to run. And it's not gonna be this, is gonna be this. So if we have the left match, we need to get the L value, and that's L match of 1% and yeah, using 10. And we just need to add first, but let's not do that. So is bigger, so this is an integer, and we have two options here. Technically, it could be bigger than 9 or it could be smaller than 9. If it's bigger than 9, we're changing a single character with the value. So what we will need to do is say we have this 7. So if we want to, we got the value of the 7, and we have another value. If the other value is 2, what we need to do is go here and just replace it with a 9, and everything else stays the same. And that's great. But if we have the case when this is 3 and we need to add it, we will need to go to the place of the 7 and add the character 1 and insert the character 0. And we can live with that. But if we are starting with 10 and whatever we're adding will be at most 10, 19, so we will just need to change whatever we have with 29. And I think this is a bit of a hypothetical situation because I think that we will only have values up to 9, but let's be careful. So if the value is bigger than 10, then L result is of course L value plus first and L index is actually L match dot index. Yeah, L match index. That's this value here. Actually we can use, and we can say result dot splice yeah, let's have it like this. So these are the characters of input. We're gonna need to splice, and splice is a magical method that basically can do almost anything to an array. So we're gonna need to delete some kind of some items and add others on their place. So we will need to add remove at this position, so at the index, no, we're gonna start at the match dot index, and we're gonna remove 2 items because we have a 2-digit number, and we're gonna add the result. And this will actually be a single item, so we're gonna split it to the digits and spread it, something like that. So this is if L value is bigger than 9, if we had a situation when we are moving from 1 to 2. Else this is less than 9, so L result is this many, And now we need to do if L result is bigger than 9. That means that we need to, actually we don't care. What we do care is that we need to remove one item, and then how many digits are in L result, just push them in. So that is the result that we have. And I think that we shouldn't be using input. Yeah, we can do that. We need to do that because input is a string. So we said we don't have this, and actually I would have tripped myself up. In this situation, if I started working from here, and basically we have this as an input, and if I go in, because we still haven't removed this from here, we have this situation, and now I went in and written 15 here. And if I'm still working with the same indices, now instead of having this thing, if I try to look at it again, I will get this thing. So I will be one off. So this thing, the left replacement happens before in the string. And you really don't want to do that. So first of all, I will do the right thing, and that's the one that happens after me in the string. And if it happens after me in the string, basically it cannot do anything to me. It cannot change the indices that come before it. And now we need to match these situations. So we have this value, and we need to find the first number, and we had this value, and we needed to find the first number, and in this case this value, and we needed to find the first number. And I think the same regex will be quite okay for us, only now it's the other way around. Yeah, we got the 4, and we got the 9, and we got the 1. Cool. Start and continue. Let's just make sure GHD. So we're just gonna take input and slice starting from yes, here, index plus the length of boom, and I'll just console log the right one. Yep. So we have that. So we're gonna need to have right args, that's this thing, and we're gonna need to have const air match, Yep, match it. If we don't have a match, actually if we don't have a match, do nothing. If we do have a match, what we need to do? Something like this. We are getting the right value. This is the right value. And we might need to do something very similar to this. If our value is larger than 10, then this result is our value plus second, and splice on the result, but we need index plus boom.length plus, and now we have ermatch.index because we have the part up before the match, the length of the match itself that we're exploding, and any additional characters that we had to skip to get to the actual number. And then we're just gonna remove two values because this is bigger than 10, and first the same thing for the case when this thing is bigger than 1, is less than 10. Actually, we could just do it, we can just do better. The let count. So if r value is bigger than 9, then it's 2, other one is 1. And we can have the same thing here, only it's L value. And we're just putting the lit count here. And we don't need this, and we don't need this. Okay, this looks much better. And now the one final thing that's left at the point of index, delete boom and insert 0. Let's see what happens. If we get to here, break, because we still haven't implemented split. This is a bit of a funny and hazy implementation, but let's see, maybe it works. No, it doesn't. We have a 0, we have a 7, we have something. First of all, let's determine what we have and what we need to get. So we have this, and we need to get, instead of this, we need to replace it with 0, and this 4 needs to be replaced by 7. So 074784, and what we got was this thing, which looks like he eats weird little brother. Aha! Seems that only thing we are missing is a +1 somewhere, because instead of replacing the 4 with the 7, we replace the 7, the comma with the 7. And let's see this thing. This is the input, and what we wanted to get was, we had to replace this with a 0, and the 7 becomes 15, and the 9 becomes 13, and what we actually got, again the length is totally correct, but I have no idea how we got from this to this. Okay, let's just constrain ourselves on our first example and try to see what happens. So we have our result. Input, we need to explode it. Yep, 37 items. We're getting to here quite nicely. And how much is index? Index is 4. Let's see what result.4 does. Where are you, result? Yep, 4 until 8. So boom has the value. Yep, that one. Do we have a match? Yep, we do. The first one is 4, the second one is 3. We should not have a match on the right. Oh, we do have a match on the right actually. And that's the 4, the first 4. So the index is 0. Oh. How do I get this? Their value is 4, the delete count is correctly 1, the add result is 7, and I thought this would be the index of the group. Now this is an error on my side, because apparently I have no idea how this thing works. So this worked in this situation because the last thing we're matching is actually matching on the left will work, but matching on the right won't. Because if we have this, and then we do, for example, this. The index that we're getting will always be 0, because we're saying start the match from the start. Maybe we need arrays.exec this. How do we get the groups? How do I get the indices of groups in JavaScript regular expression? That's stupid. Isn't there a simple? No, this is just how it runs. Let's see if name groups are doing anything. How was the syntax for name groups? It's actually something like this. Let's try it on the console first. Let's call this G1, and now I just get it as the group name. You know what? We can write some bad code. Yeah, air match index will by definition always be 0 since we have this thing. So we need to find the index. Nope. Is 0 while right of index let's have it like this. Yeah, we can have something like this. So while it's included in the array of invalid characters, just increase the index. So we have an array of all the characters that are invalid, and that's comma, open bracket, close brackets. Well, that array includes the item increase index. So we're gonna use index here, and let's try our luck now. We're just running for the first one, and let's see what we expected and what we got. We expected that, and we got perfect. This is great. So going back to the second and the third value, and let's try it once more. Okay, no breakpoint, living wild. We already mentioned that this is great and wonderful and everything. So we needed to explode this value at 8.4, 8,4, and we needed to basically remove this and put in a 0, and this changes to 7 and 8, 15, and this changes to 13. What did we get? Looks like we got what we wanted to do, and then split. So, and then we had this thing that we wanted to explode on 6 and 7, and that means that this becomes 0, and this becomes 6, and this becomes 8. Is that correct? Yep. And apparently we can explode snailfish numbers. So I will take a small break, but for you watching the video it will just be a quick pause. And we're back, and we're gonna continue splitting this. So far we think that we have explode done to a, so to say, science. But now for the split. And the split, if I'm not mistaken, should be a bit easier to do. Again, I'm gonna use my trusty regexes. And this is gonna be a dirt simple one. Let's actually leave those that we have. So we just need to find this /d/d. Anything that is bigger than 10. We don't even need a group, we can use the full match. And if this matches, then we have a split, and then we're gonna split that. And if we try it on this one, let's say match on /d/d, we matched 15 at index 13. So basically what we want to do is replace this with, actually we can add a replacer function. And for that I will need to see a bit about the documentation of string.replace JavaScript. What was the replacer function exactly? The replacing function accepts a lot of parameters, and actually, yeah, I will try to do that in TypeScript to actually get better so to say feeling for it. But on the other hand, we also need to return the value of this, so we might want to do it the okay way. So our regex is this, and then we just need to say match is input dot match using that regex. If we have a match, else return false and input. If we have a match, we're gonna split it, and we need to take the match value. Yeah, we're gonna need the index, and the value is actually percent of match of 0. Yeah, we don't need any capturing group because we're taking the whole match. If we have a match, we have the value, and then left is mat.floor value divided by 2, right is mat dot, is it the other way around? Let's see. Split, 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 split. The left element is rounded down, the right element is rounded up. So 10 becomes 5, 5, 11 becomes 5, 6. Yep, this is seal. Value divided by 2. Okay, so we have everything, and then result dot splice. We need to splice, and we need to splice at the matches index, and we need to splice 2 items because that's the highest value that we're gonna get, and we need to add a few elements. Change will be this string actually, will be this, and then the left one, and then a comma, and then the right one, and then this. So we need to change our huge number with this, and I will say just put in everything that's inside change and return true and result.join. Let's try it on a huge example. Actually, let's add a bit of commentary. We're gonna split input at index match dot index, and the value will be match of 0. That's okay. And so let's try the reduction of this thing. Let's see what we got. I don't think we got what we needed. So we had 2 explodes, followed by 2 splits, and then we got nowhere. And so we have 1, 2, 3, 4, 3, 2, 3, 4, 3, 2, 3. Let's add this so I know what is the input and what is the output. Split is one of those verbs which are the same, and it doesn't really make any sense, but it is what it is. So let's see, after the first explode we should have this. That is identical. After the second explode we should have this. And that is not identical. Yeah, those 3 are the same. And it says we should have this. Let's try to explode this one manually. Seems that we do have a bug in the explode. So what we're doing with the explode, we're taking this as the left part, we're taking this as the right part, and we're adding a 0. And then for this we are changing it to 15, and this we are changing it to 13. So I get that we are supposed to get this value, and we somehow managed to get this value. How? And what's weird, this is actually valid. No, this is not a valid number. Yeah, so this is the input that we're messing up. Just a second. So let's just run through an explode call through this. We can also just run through an explode call. Yep, this is wrong. Let's see where we are messing up. Yeah, we're gonna find the fifth bracket, and we're gonna so 4 and it's at index 16. Let's see if that is actually correct. Yeah, it has to be that. So this is our match. The first one is 8, the second one the right one. The right one is comma 9. Yep, that's correct. And we're trying to find it. We matched. The R value is 9, the delete count is 1, the result is 13. We should have an R index of 1, so the result, you can see we have 9 here at the 22nd position out of 33 total, so basically what we should have 34 total, and at the 23rd second position we should have 13 instead. So yeah, this is valid. So the right one is okay. The left one, did we match? Yeah, we matched with the 7. What is the L value? It's 7. What is the delete count? It's 1. What is the result? Is 15. So what we need to do is that at position, where are you? 13, we should add a 15. So we have 34 total, we should have 35 total. Yeah, the length is 35, and we have at position 13 the 15. And then we have a comma, tuk tuk, 8, 4. So now what happens? At index 16. Oh, no. We need to do that. I was talking about this, and that we need to go from the back to the front. So I noticed that the left one may turn off the right one, but I didn't think that the left one might turn off the actual match, so to say. So we need to splice before we analyze. So this won't change anything, even if we splice this before. So we are the order that we are fixing in the result is the right one, then the match, the boom, and then the left one. Let's see what this will do. We got this, and we were supposed to get this. Identical. Okay, now let's go back to our solution, reduce of the whole example. We need to reduce this. Let's try it without breakpoints. And it says the final value is this. Let's see if the example agrees with that. It does. Once not reduce actions applied, the Snellfish number that remains is the actual result of the addition operation, blah blah blah, this. Okay, that's great. So now we need to actually implement something. So in order to process the input, we're gonna be returning a list of strings, so it's not a list of numbers as the default. String, string, and string, string. So in order to read the lines, we just need to read the lines. So what we need to do now is basically to start with the first one and add them and add so on and so forth. So we have let result is input of 0 for index from the length of input. This is the element, and we're not gonna start as 1. At 0 we're gonna start at 1, and we're just gonna say result equals addition of a result and the element. And console log result. Let's just see if this thing works. So we said that this is the first non-trivial example when we actually need to do some stuff. Three zero five three four four five five. 30534455. Okay. 1 2 3 5 6 6. If we add 6 6 to the bunch, 50745566. Okay, a slightly larger example. Eight seven 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 8677 076687. Looks like we got the calculation part down. So let's remove the console logs. We don't need that, we don't need that. We need the other ones. So we can actually go to the actual task. We need to calculate the magnitude. And the magnitude is actually how I assume this whole thing will run, because we need to parse it into some kind of a tree, so to say, and then from the tree we can get a value. And we will have, I will call this just a number 3. So how do we get this kind of a number into a number tree? Again, we're gonna have to parse it a bit. So, how do we do that? Well, we're gonna have a stack. of values. And what we're gonna do, so this is a relatively simple format. And what we can do is, well, actually we can parse it distinctly linearly. We don't need a stack, we don't need recursion, we don't need anything else. We can say if the first character of input, actually the first character of input would always be will always be a opening bracket. But let's do that. If input of 0 is an opening bracket, then we're gonna do it the other way. Then what? So how do we do this in essence? Start with this. If we have this scenario, it's easy. Yeah, we might need a stack anyway. Let's just say return that as number 3. And we're gonna just keep going forward. There is actually a linear change, because we will have to have some kind of a combination of things. What happens if I change this with this format, let's say, and then change this with this format? Let's try that. Not to have a number 3, but I have to have a get magnitude that returns a number. So, and I'm gonna do a little more regex since we turned on the regexes. So, if our number is in the format a literal thing, then some numbers, then a comma, then some numbers, and we might need the numbers. Yeah, let's do that. So I can say input dot replace this, and then I have a replacer function which I will have to read upon. What is the second parameter? Actually, you know what? I haven't used this in a while, but I will try to see what happens. So I will just say write out the arguments. Let's see what we are getting. And return an empty string. And return a 0, so this thing is happy. And then we can just say get me a magnitude of this. This is cool. So what we're getting is all the places and all the values that we managed to get. And we're getting the index and the full thing. Yeah, this will be enough. So in essence, we're gonna change each number with each of these number with its magnitude. So as the arguments we have the first one, which we don't need, and then we have the second one, which is the first item, which is a string, which is also a string, and then we have the index, which is a number. And that's all that we need. And we need to return what do we want to change them with. And actually we don't need the index because we're just gonna return the magnitude, which is calculated by multiplying the first one, the left one by 3 and the right one by 2. So 3 times f plus 2 times s. To string. And of course this one is idempotent, so we're gonna do this. It's actually mutable, not idempotent. Yeah, you see that we changed some values with some values. So we can do this. Let result equals input, while result dot Well, the first item of result is equal to a open brace, which means, well, this thing is still a snailfish number, run it through. Replace all the matches, and this will run until it runs out of steam, so to say. And I wanted to basically match this on each run to see how we're doing, whether we're getting somewhere or not. And you can see, so the first time we made it simpler and simpler and simpler, and eventually we got to a pure number, which is 3250, which is, I have no idea if it's correct or not, because I have no idea what we started with. Yeah, let's test with these. So we're gonna have to do console log of get magnitude of this, yes, and maybe I should have copied the comment. So the first one we have no idea, but 143 yes, 1384 yes, 445 yes, 791 yes, 1137 and 748888. Okay, let's assume that is running, so we can remove this, and we're not returning 0, we are returning % of the result. So instead of console logging result, we're just gonna get the magnitude of the result. So for given this homework assignment, it's that the same 0, no. Let's get the homework assignment, and that homework assignment should have a magnitude of 4140. Yay! This was way more complicated than I thought it would be. And this is usually why I want to do regexes instead of just doing string management, because it's easy for the one or two cases, but then you get to the complicated part. Fortunately, we managed to solve the first part. We have a single gold star, and now we need a second question on the back of the homework assignment. What is the largest magnitude you can get from adding only 2 of the snailfish numbers? Note that snailfish addition is not commutative, that is... So, now what we need to do is basically do something else with this. So more or less the second start we're getting for gratis, because this part was kind of hard up till now. So what we need to do, what is the maximum magnitude? The maximum magnitude is, okay, 0 is a nice starting point because we have positive numbers, so any magnitude will be positive. Yeah. And this is not element, this is first. Actually, I will rename this findex, and we will have another one that is called syndex, that basically runs through all of the pairs. So now basically what we need to do is get all the possible pairs and add them together, see which one is the largest. There might be an analytical solution, but I'm not even gonna attempt it because it's a complicated format. I have no idea, just looking at a number, what will be the magnitude of its magnitude, so to say. So the only thing that we need to worry is that, yeah, the first part. Well, actually this thing wrote it for me. So if the first index is equal to the second index, then we are just adding the same number twice. Don't do that. Otherwise, get the first one, get the second one, add the first one and the second one, get their magnitude. If that magnitude is bigger than the maximum, it's the maximum. So this ends that one, this ends that one, and we just need to do return the maximum. Of course, let's test it. The last example, homework. This should give us, for all 90 combinations, 3993, which is the largest one. So, given our big input, $45.63. Where is it? Where is it? Yeah, here. 45.63. Let's see. That's the right answer. We got our second gold star, and this was it wasn't a hard task. I had never any doubt whether I will be able to solve it. Only I knew that it will be tricky to get every last detail correct and wrong, so we needed to be focused, we needed to debug, we needed to test on all of the cases, and that's why it was tedious. Let's run it without the input just to see how fast it is. It's not very fast. So for the full input, it took about a second for all the combinations. But I just don't see any way of determining a magnitude of the addition just by looking at the number. I'm quite guessing that, for example, the numbers that we used did not include this number, but to be honest, I cannot be sure. There will have to be a lot more analysis in order to see which number is kind of bigger than another number. Because if we know that, we can then just say, well, these are the two biggest numbers, and of course they have the biggest addition. So totally now we are at 5.5 seconds, and so far I'm fine with it. So 17 done, 18 done actually, and only 7 to go. See you tomorrow and keep developing.